Lesson. Exponential equations and U substitution. I basically look at how exponential emerging technological changes runs counterintuitive to the way our linear brains projections about change, and so we don't realize how fast our future is coming. Jason Silva. Question 1. 4 raised to the power x minus 2 raised to the power x plus 1 equals 8. The domain is the set of real numbers, and this is an exponential equation because the bases 4 and 2 are constants, as well as the variable occurs in the exponent. Our goal is to create the same base and exponent. So to do that, we first replace 4 by its prime factorization. Parentheses are needed to protect the exponent 2 against the other exponent x. Important. 2 raised to the power 2, everything raised to the power x, does not equal 2 raised to the power 2 raised to the power x. And we'll see this, for instance, 2 raised to the power 2, everything raised to the power 3 is equal to 2 raised to the power 6, which equals 64. But when we take 2 and raise it to the power 2 raised to the power 3 with no parentheses, that's equal to 2 raised to the power 8, which is equal to 256. So in conclusion, to have or to not have a parentheses is very important. So, equivalent to 2 raised to the power 2, everything raised to the power x, minus 2 raised to the power x plus 1 equals 8. Here we want to apply the power to power property, where the exponents in power to power can be interchanged because multiplication is commutative. So, a raised to the power m, everything raised to the power n, is equal to a raised to the power m times n. Similarly, a raised to the power n, everything raised to the power m, is equal to a raised to the power n times m, which equals a raised to the power m times n. So in doing that, we get the equivalent 2 raised to the power x, everything raised to the power 2. Applying the multiplication property of exponents, which dictates that a sum in the exponent expands into a product of powers of the same base, with the exponents the terms of the sum. So expanding that negative 2 raised to the power x plus 1 results in negative 2 raised to the power x times 2 raised to the power 1. Finally equals 8. Performing U substitution, where we let u equal 2 raised to the power x, such that u is greater than 0, equivalent to u raised to the power 2 minus 2u, which equals 8. This is a quadratic equation, so let's complete the square. Add plus 1 on both sides of the equation, which is equivalent to u raised to the power 2 minus 2u plus 1 equals 9. Compressing this trinomial into a binomial square, equivalent to u minus 1, everything squared, equals 9. And because of difference of squares and the zero product property, there are two possibilities. U minus 1 is equal to 3, or u minus 1 is equal to negative 3. The first possibility leads to the answer u1 equals 4 and u2 equals negative 2. U is greater than 0 as we specified, which means there's only one solution. u1 equals 4. And since 2 to the x equals u, 2 to the x equals 4, which is equivalent to 2 to the x equals 2 to the 2. And if we let f be the function f of x equals 2 to the x, replacing 2 to the x by f of x equals f of 2. And since the exponential function is a one-to-one function, we can remove that function without losing or gaining any solutions. This results in the equivalent statement x equals 2, which belongs to our domain. Thus, our set of solutions is the set made of 2. Question 2. 12 times 4 over 9 raised to the power x minus 35 times 3 over 2 raised to the power negative x plus 18 equals 0. The domain is the set of real numbers. And this is an exponential equation because the bases are constants and the variable occurs in the exponent. Our goal is to create the same base. 4 over 9 equals 2 over 3 everything squared. 4 over 9 raised to the x equals 2 over 3 raised to the second everything raised to the x, which equals 2 over 3 raised to the x, everything raised to the second. Three over 2 is equal to 2 over 3 raised to the negative 1. 3 over 2 raised to the negative x equals 2 over 3 raised to the negative 1, everything raised to the negative x, which equals 2 over 3 everything raised to the x. Let's let u equal 2 over 3 everything raised to the x, such that 4 over 9 raised to the x is equal to u squared. And 3 over 2 raised to the negative x equal u. So this results in the equivalent statement 12u squared minus 35u plus 18 equals 0. And this is a quadratic equation in standard form. So to solve it, we can use the quadratic formula, complete the square, or use the break and group method. And we can't forget about synthetic division. In this case, we are going to use synthetic division. The factors of 12 are 1 and 12, 2 and 6, 3 and 4, and the factors of 18 are 1 and 18, 2 and 9, 3 and 6. The possible zeros are thus plus or minus the set made of 1, 2, 3, 6, 9, 18, 1/2, 1/3, 1/4, 1/6, 2/3, 3/2, 3/4, 9 over 2, and 9 over 4. Since u is equal to 2 over 3 everything raised to the x, let's try 2 over 3. So we take down the coefficients of the equation, which are 12, negative 35, and 18 respectively. The possible root that we're testing is 2 over 3. Bring down the first coefficient, 12. Multiply it across, so 2 over 3 times 12 equals 8. Add that diagonally to that negative 35, and the result is negative 27. Then we multiply across again, so 2 over 3 times negative 27, which equals negative 18, and add it to 18 as we add diagonally yet again, which equals 0, which is the remainder. We have a remainder of 0 in this case. So u1 is equal to 2 over 3. 12u minus 27 is the other factor of this trinomial. Thus, solving that gives us u2, which is 27 over 12. And once we reduce that, we get the equivalent u2 equals 9 over 4. So, our first case, u equals 2/3, where u equals 2 over 3 everything raised to the x. From these two statements, thus, 2 over 3 everything raised to the x equals 2 over 3 everything raised to the 1. The left-hand side is our f of x, and the right-hand side is our f of 1. F is a one-to-one function. The function can be removed without losing or gaining solutions, which is equivalent to x equals 1, which belongs to our domain, which was the set of real numbers. Testing our second case, u equals 9/4. So using that previous statement that indicates u equals 2 over 3 everything raised to the x, from those two together, thus 2 over 3 to the x equals 9 over 4, which is equivalent to 2 over 3 raised to the x equals 2 over 3 raised to the negative 2. The left-hand side is our f of x, and the right-hand side is f of negative 2. And since f is a one-to-one function, we can remove it without losing or gaining any solutions. Equivalent to x equals negative 2. Negative 2 belongs to our domain of real numbers. So x2 equals negative 2. Thus, the set of solutions is the set made of negative 2, 1. Question 3. 2 raised to the power 1 minus x plus 2 raised to the power 1 plus x equals 4. The domain is the set of real numbers. And let's start off by applying the division property of exponents. A subtraction in the exponent expands into a quotient of powers of the same base with the exponents the terms of the difference. So for 2 raised to the power 1 minus x, that equals 2 raised to the power 1 divided by 2 raised to the power x. Apply the multiplication property of exponents, which we know to be an addition in the exponent expanding into a product of powers of the same base with the exponents the terms of the sum. So 2 raised to the power 1 plus x is equal to 2 raised to the power 1 times 2 raised to the power x. Then we want to perform a U substitution. Let U equal 2 raised to the power x. And U is greater than 0. Equivalent to 2 over U plus 2U equals 4. This is a rational equation, so let's eliminate the denominator. Multiply both sides of the equation by u, where u does not equal 0. Applying the distributive property of multiplication over addition, equivalent to 2 plus 2u squared equals 4u. The GCF of all the coefficients is 2, so we can divide both sides of the equation by 2, which is equivalent to 1 plus u squared equals 2u. This is a quadratic equation. Let's write it in standard form. So subtract 2 on both sides of the equation, equivalent to u squared minus 2u plus 1 equals 0. The trinomial compresses into a binomial square. So that's equivalent to u minus 1 everything squared equals 0. The special quadratic equation has a double solution, which is equivalent to u1 equals u2, which equals 1. U is equal to 2 raised to the power x, and u equals 1. Thus, 2 to the x equals 1, which is equivalent to 2 to the x equals 2 to the 0. And if 2 to the x is our f of x, 2 to the 0 is our f of 0. And because f is a one-to-one function, the function can be removed without losing or gaining any solutions, equivalent to x equals 0, which belongs to the domain. Thus, the set of solutions is equal to the set made of 0. Question 4. 1 over 4 raised to the power 1 minus 3x plus 2 raised to the power 3x plus 1 equals 1 over 4 raised to the power 2 minus 3x plus 2 raised to the power 3x plus 3. The domain is the set of real numbers. So let's get to work. 1 over 4 raised to the power 1 minus 3x. Factor negative 1 in the exponent equals 1 over 4 raised to the power negative the quantity 3x minus 1. Negative sign on the exponent means the reciprocal. So it's equal to 4 raised to the power 3x minus 1. And we'll do the same kind of trick on 1 over 4 raised to the 2 minus 3x. It equals 1 over 4 raised to the negative the quantity 3x minus 2, which equals 4 raised to 3x minus 2. The equation is equivalent to 4 raised to the power 3x minus 1 plus 2 raised to the power 3x plus 1 equals 4 raised to the power 3x minus 2 plus 2 raised to the power 3x plus 3. And our goal here is to create the same exponent and the same base. So let's create the same exponent first. To avoid fractions, let's choose the lowest exponent, 3x minus 2. So this is equivalent to 4 raised to the power 3x minus 2 plus 1, because minus 1 can expand into minus 2 plus 1, plus 2 raised to the power 3x minus 2 plus 3, because positive 1 expands into negative 2 positive 3, which equals 4 raised to the power 3x minus 2. We don't change it at all because that's the lowest one we're trying to get everything to. plus 2 raised to the power 3x minus 2 plus 5, because positive 3 expands it to negative 2 plus 5. Let's apply the multiplication property of exponents. An addition in the exponent expands into a product of powers of the same base with exponents the terms of the sum. So this is equivalent to 4 raised to the power 1, which is 4, times 4 raised to the power 3x minus 2, plus 2 raised to the power 3, which is 8, times 2 raised to the power 3x minus 2, which equals 4 raised to the power 3x minus 2, plus 2 raised to the power 5, which is 32, times 2 raised to the power 3x minus 2. We will now create the same base, namely 2. So, equivalent to 4 times the quantity 2 raised to the power 2, everything raised to the power 3x minus 2, plus 8 times 2 raised to the power 3x minus 2 equals the quantity 2 raised to the power 2, everything to the 3x minus 2, plus 32 times 2 raised to the power 3x minus 2. The exponents of a power can interchange. So interchanging the first, we get 4 times the quantity 2 raised to the power 3x minus 2, everything raised to the power 2, plus 8 times 2 raised to the power 3x minus 2, which equals the quantity 2 raised to the power 3x minus 2, everything squared, plus 32 times 2 raised to the power 3x minus 2. Let's do some U substitution. So if we let U equal 2 raised to the power 3x minus 2, where U is greater than 0, equivalent to 4 times U squared plus 8U equals U squared plus 32U. This is a quadratic equation, so let's write it in standard form. Equivalent to 3U squared minus 24U equals 0. And let's factor the GCF, which is 3U. Equivalent to 3U times the quantity U minus 8, which equals 0. Utilizing the zero product property, we get our first case where U equals 0. U is greater than 0 because U represents the value of an exponent, and thus it must be positive. Thus, U cannot equal 0, and we throw that case out. So our second one is U equals 8. That's all good to go. So U also equals 2 raised to the power 3x minus 2. Thus, 2 raised to the power 3x minus 2 is equal to 2/3. Let the exponential function f, such as f of x equals 2 raised to the power x. So our left-hand side is f of 3x minus 2, which equals our right-hand side of f of 3. The function is a one-to-one function, so we can remove it without losing or gaining solutions. Equivalent to 3x minus 2, which equals 3, which is equivalent to 3x equals 5, which is equivalent to x equals 5 over 3, which belongs to the domain of the set of real numbers. Thus, the set of solutions for this problem is equal to the set made of 5/3. Question 5. 3 plus 9 raised to the power 3 over x, everything over 3, equals 1 plus 27 raised to the power 1 over x. Domain, set of real numbers. So this is an exponential equation because the bases and 9 and 27 are constants, and the variable occurs in the exponents. So our goal here is to create the same base and the same exponent. To accomplish that, the first thing we're going to do is replace the 9 and the 27 as powers of 3. So, equivalent to 3 plus the quantity 3 squared, everything raised to the power 3 over x, everything over 3, equals 1 plus 3 raised to the power 3, everything to the power 1 over x. So by applying the power property of exponents, which dictates that power to power, you keep the base, multiply the exponents. So a to the power m, everything to the power n, is equal to a to the power m times n. So this is equivalent to 3 plus 3 raised to the power 2 times 3 over x, everything over 3, equals 1 plus 3 raised to the power 3 over x. Now let's apply the power of exponents property in reverse, where a to the power m times n is equal to the quantity a raised to the power m, everything raised to the power n. So, equivalent to 3 plus the quantity 3 to the 3 over x, everything squared, everything over 3, equals 1 plus 3 raised to the power 3 over x. And we did that so we could have the same kind of 3 to the power 3 over x on both sides of the equation. That's just in time for us to use our U substitution. So let's let U equal 3 raised to the power 3 over x, where U is greater than 0. So, equivalent to 3 plus U squared, everything over 3, equals 1 plus U. Eliminate denominators by multiplying both sides of the equation by 3, equivalent to 3 plus U squared, equals 3 plus 3U. This is a quadratic equation. Let's write it in standard form. Add negative 3 and negative 3u on both sides of the equation. Equivalent to u squared minus 3u equals 0. Factoring the GCF, which is u, equivalent to u times the quantity u minus 3, which equals 0. U is greater than 0, thus u equals 3. We know that u equals 3 raised to the power 3 over x. Thus, from those two statements, 3 raised to the power 3 over x equals 3, which is equivalent to 3 raised to the power 3 over x equals 3 raised to the power 1. Now, if we let the exponential function f, such that f of x equals 3 raised to the power x, our left-hand side is f of 3 over x, which equals our right-hand side, which is f of 1. F is a one-to-one function, and we can just get rid of it without losing or gaining any solutions. Equivalent to 3 over x equals 1, which is equivalent to x equals 3. This belongs to our domain since our domain is the set of real numbers. Thus, we can conclude our set of solutions is the set made of 3. The end.